Hi everyone. In this video, I'm going to be discussing some important topics that you will be learning about in Module 1. Um, so before we do that though, I want to provide a self-introduction. My name is Tyler Poe, and I am a NKU senior student and a master teaching assistant. This will be my second semester as a master teaching assistant and my third overall as a teaching assistant. I took this course last year during the the spring 2021 semester, and in the following semester, I was this class's master TA. Last semester, as master TA, I recorded mini lectures, created command guides, and offered Zoom office hours. I also answered students' emails and provided some help, which you can in this semester as well. If you need help, you can just email me and set up a Zoom appointment. I'm happy to help you and answer some quick questions if you have them. In addition to what I've done here in this semester, my plan is to edit some of the command guides. They were created for a 7-week section. I'm going to make them more I'm going to make them more accessible for this full full semester class. I'm also going to be creating new lectures like this, which should help you understand some topics that you need to understand for labs. And also, I'm going to be redoing one of the lab assignments, which you don't need to worry about that right now. That's going to be much farther down the semester. But anyway, let's go over the topics I'm going to be discussing today. So I'm going to be discussing the OSI layers. I'm going to be discussing some specific details between layer 2 and layer 3. We're also going to learn about broadcast domains and LANs. And finally, I'll do a discussion on the ARP protocol and the ping command, which will be very important to understand for the lab assignment in this module. So let's do a brief review of the OSI layers. Now, I'm pretty sure that you all have probably encountered the OSI model before in other networking classes. Depending on whether you're a transfer student and how much details they put into this, you may not completely understand it or not, or may not completely understand it. But if you've taken like the CompTIA Network Plus, you should. But this this model is pretty important to this class, particularly the second and third layers, which I'll be going over all of them, but just keep in mind the layers highlighted in green, especially the second and third one here, are what this class focuses on mostly. So layers are counted from bottom to top, starting with layer 1, which is the physical layer. This layer in the OSI model is basically your cabling, your NIC, and your hubs. So basically, you can think of the OSI layers this way. So when say you have a network, like a switch, you have a switch, and you have two computers, and you have the cables that connect all those devices. So basically, you get from more general to more specific in how the network traffic is edited or how it's presented to you or formatted. So for the very basics, the physical layer is the most basic one. It's the cabling, it's your NICs on your devices, and you also have hubs here. Hubs are layer 1 devices. They allow devices to communicate with each other like a switch does, but they're very incompetent and they don't have a lot of they're missing many of the features switches have. You should honestly hubs, they're evil. They cause a lot of problems and you never want to use them. But anyway, after that, we get a little more specific with the data link layer. This is where switching occurs. So you have switches, obviously, as layer 2 devices. Bridges are also layer 2 devices, but we don't really use them in this class. Also, addressing in layer 2 is known as MAC addresses. These are physical addresses, which I'll discuss a little later. And finally, it's important to understand that the type of communications that happen in layer 2 are called frames. Now is layer 3, network layer. This is where routing occurs. We have routers, obviously. Also, the addresses in layer 3 are called IP addresses. These are logical addresses that I'm sure you're very familiar with by now. Um, Also, the type of communications that happen, or the type of the data type in layer 3 is called a packet. So, as to explain this here, so when you have two computers here and they want to communicate with one another, like if you're using the ping command, basically the first device creates a packet containing its IP address and the destination IP address of the other device. And then this packet, when it gets sent to the switch, it gets encapsulated in a frame, a data link data type. And then finally, this frame is forwarded through the cabling from the computer, the source computer, to the switch. So that's basically how all these layers work together. That's a very important thing to understand for the lab. Now, these other four layers, they're not as important relevant to this class, but they're important to understand still, particularly layer 4. Layer 4 is transport protocols like TCP and UDP. The session layer, layer 5, is basically just control protocols and tunneling protocols. Tunneling protocols really aren't used in this class. CIT 447 will use some tunneling, will involve some tunneling, but these are some examples of some protocols in the session layer. Nothing you will be using in this class. Presentation layer is layer 6. That's encoding and encryption, such as SSL and TLS. Encryption stuff, really, again, another thing that's not used in this course, but it is important to understand. And then finally, you have layer 7, the presentation layer, which is basically your programs and applications and specific protocols that are used by these applications, such as HTTP and FTP. Also, interactable applications that we actually see, like Gmail and Twitter. So basically, communications and networking rely on all 7 of these layers. They're basically layers of they're basically, you can think of them as I said, from more general to specific. But in this class, highlighted in green, these are the 3 layers you especially need to understand for this to do well in this class. So let's emphasize some other things in layer 2 and layer 3. As I said, the devices in layer 2 are switches and bridges. The addressing used here is MAC addresses. So MAC addresses are physical addresses unique to each device. So basically, when you buy your computer, it comes with a MAC address pre-configured by the computer's manufacturer. Now, technically, you can change MAC addresses, but it's not really wise to do so. They're supposed to be completely unique in a network. It's best to not change them. So, as I said, communication in layer 2 occurs with frames, data link frames. So also, another important point about layer 2, switches only allow communication between devices in the same subnet and broadcast domain. So in other words, layer 2 communications can only happen in the same local area network or LAN. I'll be discussing broadcast domains and LANs in a minute, but let's go over layer 3. So again, devices, just routers. IP addressing, these are the addresses used in layer 3. IP addresses are logical addresses and usually can be easily changed. You've probably had some classes like in network or Windows administration or like Linux administration where you've changed IP addresses. You've probably even done it yourself in your own computer. But typically, IP addresses there's protocols that change IP addresses for you, like DHCP. DHCP is covered in this class, but it's kind of a small topic at the very end. But anyway, you'll be changing IP address, configuring and changing IP addresses a lot in this class, so keep that in mind, please. Also, communication occurs in packets in layer 3. And then finally, important points about layer 3. Routers allow devices in different subnets and LANs to communicate. So in the layer 2 LAN, all the devices in that LAN need to be in the same subnet and need to be in the same broadcast domain, which they are. But routers allow devices in one LAN to communicate with devices in another LAN. That's an important point about layer 3. So let's now discuss broadcast domains and LANs. They're basically the same thing, which I'll discuss in a minute, but the definition for a broadcast domain is a set of devices for which, when one device sends a broadcast, all devices receive that broadcast. So basically, say you have 4 computers connected to the same switch. Let's say the first computer sends a broadcast communication. So that broadcast goes to the switch, and the switch actually forwards that broadcast to all of the other devices in that network. So all devices connected into a non-VLAN switch are in the same broadcast domain. Conversely, routers and VLANs divide networks into multiple broadcast domains. So let me see here. VLANs basically are virtual LANs on a switch. So basically, you can actually create multiple LANs on the same switch. instead of having a router do so. But we'll deal with VLANs later. All you need to know is that they divide a switch into multiple broadcast domains. Routers do the same thing, but basically a switch in its base form is basically all the devices connected to the same switch are in one broadcast domain. So a LAN is a local area network, hence the name, in which all devices are in the same broadcast domain. To communicate, all devices in a LAN must be in the same subnet. So subnetting is a major topic in this course, but it will be dealt with later. Just know that this network here, this is a subnet. So basically, it's a group of IP addresses that the devices in the same LAN can use to communicate with each other. So let me see, 0.255. So actually, yeah. So devices that are not inclusively between these addresses, devices can use addresses between this range to communicate with one another. That's a subnet. Subnetting, again, will be discussed later, but just know that's what a /24 does. It goes from 0 to 255 in the last quartet in an IP address subnet, or range, excuse me. So finally, a LAN is a layer 2 network, while a subnet is a layer 3 network. This is very important to understand for the lab. A LAN is a layer 2 network, while a subnet is a layer 3 network. Another very important topic, two devices in the same LAN can be in different layer 3 networks. So while two devices can be in the same LAN, they can actually not be in the same layer 3 network. They can't communicate with each other, but they can be that way. And to explain this, let's use this little diagram I created. So we have two circles here. These two circles represent different LANs or broadcast domains. So all the switch and the computer here and this interface of the router are all in the same broadcast domain. Notice how they're all in the same subnet. 192.168.1.0/24.10 for router 1 here, this interface in router 1, and .1 for PC5. These devices communicate with each other. And actually with the router here, this computer can communicate with these computers here. Notice how you see the same thing here. Subnet here, all these devices are in the same subnet. However, note that PC3 is actually in a different subnet. Now, you may ask yourself, is it in a different broadcast domain? It's not. Understand it is in the same layer 2 network. However, because it's in a different layer 3 network, it can't communicate. So PC3 is in the same layer 2 network or broadcast domain, but it's in a different layer 3 network. That's very important for you to understand for your lab. So let's discuss some things about ARP. So before two devices can communicate with one another, they need to know each other's MAC address. They need to know each other's MAC addresses. Excuse me. So basically, when you have two computers connected to a switch, if PC1 does not know the MAC address of PC2, it won't be able to communicate with each other. Thus is why we have the protocol ARP, which is a protocol that enables devices to discover each other's MAC addresses. The following steps describe how this process works. So first, let's say a host wants to discover the MAC address of another host within the same LAN. The first host, source host, sends out an ARP request, which is a broadcasted frame that requests that the destination host's IP address be resolved to its MAC address. So basically, with an ARP request, computer PC1 is saying to PC2, "Hey, I have your IP address. Can you Can you associate your MAC address with your own IP address?" Or basically, it's saying, "Can I have your MAC address?" So the host, after this, sends out the ARP request. The switch receives that request, and then it forwards the source for host's frame as a broadcast. So basically, the switch receives the ARP request and it broadcasts it out to all the other devices on the LAN, with all the LAN's hosts receiving the message. Only the host with the destination IP address receives it. So you see in ARP how IP addresses work together with MAC addresses. So layer 3 and layer 2 are working together. So the destination device, when it after it receives the ARP request, sends back an ARP reply, which is a frame that contains the device's MAC address. So basically, this ARP reply contains the destination device's MAC address. The switch then receives this frame and sends it to the source device. This device then adds the destination device's MAC address to its own MAC address table, and then the computers can communicate with each other now because they know each other's MAC addresses. So the details on how switches actually learn MAC addresses. Um, I'm sure Dr. Rana has already gone over that, and also there is a PowerPoint in Canvas that goes over that too. So I won't repeat that here, but this is a specific discussion on ARP here. So finally, we'll discuss a little bit about ping. So the ICMP ping protocol allows you to test connectivity between two devices. This is entered into a device's command prompt like this. So basically you type out the word ping, then space, and then type out the IP address of the other device you want to communicate with. So I'm sure you've already done this before in other classes, but this is a very important thing to understand in this class. You need to know how to use the ping command. It's very simple. Just type ping, or you enter the device's command prompt, you type ping, the word ping, space, and then you type the IP address. So if the source device does not know the MAC address of the destination device, ARP must take place before the two devices can ping one another. And that's why when you ping devices, you might notice some lag. That's especially apparent in some of the labs in this course. That's ARP taking place. Don't worry about it. Some of the pings will actually fail because ARP is trying to take place. That's normal as long as the ping command works after like the third attempt or the third communication, or you can try again and it works. You're perfectly fine. Just know that ARP needs to take place before ping. Now, finally, for a more in-depth review on ping and ARP, there is a ARP explanation video in Module 1 that was created by a former professor. He created a very good discussion on ping and even shows you how it works with Wireshark. So that's the end of this lecture. Thank you for watching. I hope you find this lecture very helpful. If you need more help, you can contact me by my email. Ask me some questions if you need to. Thank you for watching and have a good day.